Hello everyone. So in this video lecture, concept is process model. So let's start. So here you got this three images. Okay, so just see this image carefully and predict what does it wants to say you. Okay, let's pick up this first image. Okay, that is A. In this there are total 4 processes in RAM. Okay, so what does it mean? Multi-programming of 4 programs in memory. Okay, now in image B, it is representing conceptual model of 4 independent sequential processes, each with its own flow of control. For example, in my PC, in my computer, I am listening music. After that, in background I am downloading something video like that. After that, there is also my system is being updated, so this is third process. And after that, I am executing my C program. Okay, so I am just giving you example. Total there are 4 processes which are running simultaneously in your system. Okay, so these processes each are independent in their own way. Okay, they are running independently and they do not know which process is simultaneously executed by CPU. Okay, so they are very simple in nature. Okay, they are not like human being. If I am doing this, then I just kept my work aside and I am just looking who is doing what in my neighbor by my side. Okay, it's not like that. So all the processes are very straightforward. He or she maybe it just want to do its own task. Now after that, this figure C, okay, it represent graph of this processes over long period of time interval. All the process have made progress. That means I have downloaded 75% of video. After that, my system is updated to 50%. Okay, my program is being running by CPU. Okay, I got some compilation error and I have made some other changes over there. My music listening is also ongoing. So these all processes have made progress, but at any given instant only one process is actually running. Now let's see some example of process creation. That means if I am saying that program under execution is called process, so does that means only execution of C program comes under process? No. Whenever you do something, okay, now what kind of doing? So I'm just going to explain you in how many ways you can create process. Okay, so first of all is system initialization. For example, whenever you switch on your system, okay, at the time of operating system booting, various processes are created. Whenever you start your program, okay, there are various background and foreground processes are created. Now what kind of background process? So background process that do not interact with user. For example, process to accept mail. Okay, but obviously it is done whenever program is fully loaded. That means your operating system and you have network connection. After that, foreground process, that is interaction with user. Okay, after that, the second one is execution of process creation, that is system call by running process. Okay, now in concept of a system call, there is one system call for process management, that is fork, and fork is used to create child process. Okay, so running process will issue a system called fork to create one or more new process to help it. Okay, the process of, for example, your process, you are executing something and it the task is fetching large amount of data and execute it. So it will create two different process, one for fetching data and another to execute it. Okay, so this is your main process. Okay, and this process execute fork system call, and using fork you can create two process P2 and process P3, where P2 fetch large amount of data and P3 just execute this data. Okay, after that a user requests to create a new process. Okay, for example, start process by clicking on icon. Whenever you double click or you just execute command, then you are creating new process. For example, if I am just open this Microsoft Word, so it is also called process. Initialization of batch process, but usually it is applicable to only batch system found on large mainframe. Okay, after that let's see process termination. Okay, so one is normal exit, voluntary, that means if I'm just shutting down this system, okay, terminated because process has done its work. So for example, if I'm just closing this file, okay, so it is normal exit. After that error exit, okay, which is voluntary. Now for example, the process discover a fatal error. For example, if I want to open some file, but you got message like no such file exists, and for example in my command prompt I want to compile this foo.c file, but what I got is something like this, the file does not exist. So over here this process is terminated because we got this fatal error. Okay, after that, okay, this was error exit and this is fatal error. Okay, fatal error is like some executing illegal instruction, or we are referencing some non-existential memory address, or divide by when program contain some logical error. Okay, for example in this program you can see over here division equals to n modulo 0, n divided by 0. Okay, so this program is maybe syntactically right, but there is logical error which is divided by 0. Okay, so this program also terminated abnormally, and this comes under fatal error. Okay, so over here also program terminate, you can see. After that killed by another process, okay, and which is involuntary, that means in this kind of scenario process cannot stop itself from being killed by some another process, but some another higher priority process just kill this lower priority process, or I can say parent process killed child process. A process execute a system call telling the operating system to kill some other process using kill system call. So in this video lecture you got two system call. The first you already know, that is read. Okay, so the remaining two are, first one is fork, which is used to create child process. Okay, and this one is kill system call, which is used by processes to tell the operating system to kill some other process. Okay, now let's see process hierarchies. Parent process can create a child process. Child process can also create its own child process. For example, there is, okay, I am executing some complex mathematical program, okay, which includes more very complex mathematical formula, and I'm just going to execute that program. So this is my main program, and it require very vast calculation. Okay, it require to fetch large amount of data and then process it. So what this process P1 will do, it will create three child process, P2, P3 and P4. Okay, so P2 will fetch the data, P3 will operate on the data, and P4, the task of P4 is to pass to this outcome to certain another process. Okay, so over here P1 is child process, and this P2, P3 and P4 is child process of process P1. Okay, now as I have said, each process can create its own child process. Okay, so it may be possible that P3 cannot execute the whole task, so it is also creating some another child process. Okay, and the task is simplified, so P3 creates two child processes, that is P5 and P6. Now whenever this child process create child process, it is treated as a parent process of this P5 and P6 child processes. Okay, now Unix has a hierarchical concept which is known as a process group, but in Windows there is no concept of hierarchy. In Windows we use the concept of a handle. Okay, which treat all the process as equal. Now let's see what is handle. Whenever a process is created, parent process is given a special token called handle. Okay, so for example, there is one process P1. Okay, so whenever this process is created, this process is given a special ID. Okay, I can say ID, or I can say it is a handle. Now this handle is used to control all the child process of that particular process P1. Okay, we can control all this process using handle. Process is free to pass this token to some another process. Okay, so this is the concept of a handle. Now using this handle, using this handle we can get idea of what is the process ID, program counter, variables, registers, which are held by this particular process. Okay, how many child processes is created by this particular process. This all the information we can control this process using handle. Okay, so that's all about the process model, and it is just a theoretical concept, you just need to know. Okay, and in next video lecture we will cover state of process state model. Okay, so I hope you enjoy this video and keep smiling. Bye bye.